In this video, we're going to look at conditional probability and in particular the multiplication rule for dependent events. In front of us, we got a full deck of cards. There are 52 cards in total. We got 4 suits, clubs, spades, hearts and diamonds, and we've got 12 picture cards. The picture cards are Jack, Queen and King. What I've done is put together a bit of a practical example or explanation of the multiplication rule. We're going to follow it through and then come up with a generalization and a formula that we can use from here on inwards. So here's a Venn diagram. Event A is going to be now drawing a club. So what I've done in A, I've put all of the clubs. So event A is drawing a club. Event B is drawing a picture card. So event A is a club, so we can see in A we've got all of the numbers and then the picture cards. In event B is going to be now choosing a picture card. Outside, this represents everything that's left. Pretend they're all in neat little piles. So if we wanted to put this information on, and I'll write it here, we've got A and B. In the middle, we've got 3. On this side, we've got 10, as there are 13 clubs in total. We realise that from the pack. And over this side, we know we've got 12 picture cards, so we've got 9 in total. 22, there are 52 in the pack. That leaves me 30 on the outside. The question I'm going to ask is as follows. Given that the card we've chosen is a picture card, what is the probability that it will be a club? So I'll repeat the question. Given that the card we have chosen is a picture card, what's the probability that it's a club? We can see quite clearly from this that if it's a picture card, we can only choose from B here. And the clubs that we've got are in the intersection. And we can see that we're going to have a probability of 3 over 12, which we could break down to 1 over 4. So given that it is a picture card, the probability that it's a club is going to be 3 over 12 or 1 over 4 as we're considering picking from B and we are looking only at the intersection. This gives rise to the multiplication rule. The multiplication rule is the probability of A given B is equal to the probability of A intersection B, so A and B, divided by the probability of B. Now please bear in mind that this can be written the other way round also. So the probability of B given A is equal to the probability of B intersection A divided by the probability of A. Let's just read this. This is saying what is the probability that I get A given B has already happened, and that's exactly what we've done here. So the probability of me getting A given that it's in B also is quite clearly 3 over 12. Now if we went to the numbers only, we can just work this out by using the formula, and with the addition one, this can be manipulated in many ways as well. So the probability that I get A, which is a club, given that it's also a picture, is going to be the probability of A intersection B, which is going to be 3 of the 52 cards, divided by the probability of B, which is going to be 12 of 52 cards. Quite clearly the 52s cancel, leaving us now with 3 over 12, which of course is 1 over 4. So the way we read this is the probability that A is going to happen, given that B has already happened, is the probability of A intersection B divided by the probability of B. And hopefully that gives you an idea on how it works. So let's look at it in action, and we will do it now on an example. So A and B are 2 events such that the probability of A is 0.6, probability of B is 0.5, and the probability of A intersection B is 0.4. We need to find the probability of A union B, the probability of B given A, the probability of A given B, and the probability of A given not B. So we can use the formula. So just going back, what we can write is the probability of A given B is equal to the probability of A intersection B divided by the probability of B. So let's fill up our Venn diagram and it will make it quite clear for us what we're looking for. So the intersection from our previous work, 0.4. Probability of B is 0.5, so this must be 0.1. Probability of A is 0.6, this must be 0.2. If that doesn't mean anything to you, please review all of the material before this, as it's dependent upon it, if you excuse the pun. Okay, so what have we got in total? 0.7, so this is going to be now 0.3. We know all probabilities equal 1. The sample space must be equal to 1. So if this is 0.7, the sample space is 1 minus 0.7. So first one, the probability of A union B. We know the union is all of this in here, so that's going to be nice and straightforward. That's just going to give us the 0.7. The probability of B given A. So let's write that out then. The probability of B given A is the probability now of B intersection A divided by the probability of A. So what we've got then is the intersection is going to be 0.4. So what we'll have is 0.4 divided by 0. And now we can see that the probability of A is going to be 0.6. So we can say, simplifying that, that is going to give us 2 over 3 or 0.6 recurring. So the probability now of B given A is the probability of B intersection A divided by the probability of A, which is going to give us it's going to give us 2/3. So let's write that there, 2/3 or 0.6 recurring. So that one's B. The probability of A given B. So all we need to do is use this one here. So it's going to be the intersection, which is going to be 0.4, divided by the probability of B, which is going to be 0.5. And what's that going to give us? 4/5, which is going to be 0.8. Okay, and that's logical. We're just looking for this bit in the whole part there. So that one, C, is going to be now 0.8. The probability of A given not B. So if we write this out, what we're going to have then is the probability of A given not B is equal to the probability of A intersection not B divided by now the probability of not B. So the intersection, A intersection not B, is just this 0.2 here, and we've learned that in our previous work. So A intersection not B is just here, which is going to be 0.2, divided by the probability of not B. We can see that the probability of B here is going to be 0.5. So what we end up with then is 0.2 over 0.5, which is going to give us, what's that going to give us? 2/5, which is 0.4. So D is going to be equal to 0.4. In some later videos, we'll go on to look at independent probability and the result of this, the multiplication formula, in terms of independent probability, but we will leave that for another video. So hopefully the take-home message is as follows. If we look at this now, we can say that the probability of A given B has already happened is the probability of A and B divided by the probability of B, which of course can be written in many different forms, as we've just seen. You could have done these without using the formula and just worked them from Venn diagrams. I personally think it's much easier just to work with the formula and plug in the numbers.